Okay, now let's try to bring the second charge. So we start out at the configuration that we ended with in the last section, which was that charge Q1 now is located at a point P1, and charge Q2 and Q3 are at infinity. We said the energy in this configuration is 0. Now the next configuration is we bring charge 2 from infinity and we put it at point P2. This configuration has a different energy, some energy called UC. And we want to get what's the difference between UC and UB. UC minus UB. The energy in the configuration C minus the energy in configuration B.
Configuration is configuration B. It's characterized by having charge Q1 at point P1 and charge Q2 and Q3 at infinity. And this configuration has energy UB. This configuration is configuration C. Charge Q2 is located at point P2, charge Q1 is located at point P1, and charge Q3 is at infinity. The energy in this configuration is UC.
So, like before, the difference in energy between two different configurations is equal to the work done by the external agent to move charge Q2 from infinity along some path to point P2. And we said before that the work due to the external agent is the negative of the work due to the electric field. Okay, what is the work due to the electric field? It's integration from infinity to P2, the force on 2 dotted into dr. Now, as the charge 2 is moving along this path, is there any force on it or not? So what is the force on 2? The force on 2 in general, it's Q2, the charge, times the electric field. Now, this electric field is the electric field due to which charge? Remember, Q1 now is close to Q2. Q2 is coming close to Q1. There's finite distance between them. But still, in this configuration, Q3, how far is it from Q2 along its path? It's infinitely far away. So Q3 is not going to influence this path, the motion along the path at all. Only Q1 will. So the electric field here is the electric field due to Q1. So we can write it like this. It's Q2 times the electric field due to Q1. Okay, so we're not going to try to calculate the difference in energy using this equation. We already did this integration before, and we called it the difference in potential. So actually, remember, we can also say that the difference in energy is the charge times the potential difference. So this is the easier way to calculate the difference in energy. We already calculated what the potential difference between 2 points in space is due to a charge. So if we want the potential at point P2 minus the potential at infinity, which is 0, due to the charge Q1, because the charge Q1, remember, is the one that's making the influence on charge Q2. So we already know how to calculate this difference in potential. We already did this before. The result was very simple, that the potential due to a point charge at point P2 is Ke times the charge Q1 divided by the distance between them, R12, and that's the simple answer. So you get Q2 times the potential at point 2 due to charge 1, which is this value. So we get the final result that UC minus UB is this value. Now we know that UB is 0, so that means that UC is equal to this value directly. So UC turns out to be equal to Ke Q1 Q2 over R12. And this concludes then the parts B and C. In part B, this configuration has 0 energy. In part C, this configuration has energy Q2 times Ke Q1 over R12.